These batteries can deliver more than enough current to actually shock you to death. And I'm sure you might be like, why doesn't it shocks me? Okay, so you see there's a minimum amount of current that's required to flow through our body for us to even perceive or feel that there's electricity flowing through us. And according to a study by the IEC, it's about 0.5 milliamps. That's 500 microamps. That's when it start perceiving or feeling that there's electricity flowing through us. And at 10 times this current, that's 5 milliamps. That's when you might start having uncontrolled muscle contraction. But how much current can this battery actually deliver? So we simply just shut this output and measure how much current it can deliver. So we simply just come to the 10 amps range and we switch to the fused. Okay, so it's actually delivering more than 2 amps. That would literally kill us. But here's the catch. You see, the current that is shown here is actually the current that this battery can deliver, assuming there was no resistance. But lucky for us, our body has a very high resistance. And it's often within a range of about 1,000 to about 100,000 ohms, and varies based on the condition and position on the skin. And according to Ohm's law, it just happens to be that resistance is one of the two main factors alongside voltage that determine the amount of current that flows through an object. So if we have to increase the amount of current flowing through an object, we either increase the voltage or we reduce the resistance, or both, keeping other factors constant. So in that note, given that we have the voltage or know the voltage of these batteries and we have an approximate value for the schem's resistance, we can use Ohm's law to calculate how much current this 1.5 volt battery can push through my body. So let's pick a middle ground, right? Let us take 50 kilo ohms to act as my body's resistance, right? So according to Ohm's law, we simply just take this 1.5 volt and divide it by our body's resistance. That's 50 kilo ohms. So we punch out. Let's see what we get. So we have 1.5 volts divided by 50,000 ohms. Okay, so we're getting 0.00003. That's approximately 0.03 milliamps, which is far way below the required 0.5 milliamps for me to be perceived or feel that is electricity flowing through me. So it is one thing that if you take from this video is that despite the current rating on these batteries, if it doesn't have enough voltage to push those electrons fast enough to my body, it can actually shock me. So let's just take, for example, my modified microwave oven transformer, right? Can deliver huge amount of currents. So I will just connect to power, then put some. So you see, if I could hold it, man, it doesn't really does anything. But see what happens when you see, wow. So it's actually you can actually deliver lots of current, but you can't really shock me because it doesn't have enough voltage to push all those electrons fast enough through my body. So that's it for this video.